Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. In today's course, we will be discussing about the pattern matching algorithm. Under that, we will be seeing about the Knuth Pratt algorithm. And in this, we will be seeing one more thing regarding the example of this KMP algorithm. If you can refer the other video, the previous video regarding the pattern matching algorithm, that is a brute force. Brute force algorithm already we have discussed, and we find some disadvantages with the brute force. That's why we are coming up with a new algorithm, that is Knuth. In short, we are going to name it as KMP algorithm. Let us see what is KMP algorithm and how it is going to work, all these things. Knuth Pratt algorithm. Here, this is one of the most popular pattern matching algorithm, and this KMP stands for Knuth Pratt. And these are nothing but the persons who have invented this KMP algorithm. Let us see who have been invented this KMP algorithm. This KMP algorithm was invented by Donald Knuth and Pratt. These two people have together developed or invented this KMP algorithm, and independently by James H. Morris, right. In the year 1970, they have invented this algorithm in 1970s, and in the year 1977, all these three jointly published this KMP algorithm. Now, this KMP algorithm was the first linear time complexity algorithm for string matching. And already we have discussed at the starting of this pattern matching algorithms itself, what is this string matching. That is nothing but if you have given a text A, B, C, A. Suppose this is a text that was given. In this, I am going to check for a pattern whether it is present in this text or not. Suppose the pattern which I am going to check for is BA. If this pattern is present in this text, then we can say that this pattern is present in the text. That is, we can say the pattern is there in the text. That is nothing but the string matching. And based on this, the KMP algorithm is one of the string matching algorithm that is used to find a pattern in a text or not. Already we have seen one of the method, that is brute force, that we are finding some difficulties or disadvantages. That's why we are moving on to this KMP algorithm, and how this will be overcoming with the disadvantage of brute force, that one we will see. Now, to use this KMP algorithm, first thing you have to know what is a pattern and what is a text. To find a pattern in a text, we are going to use this KMP algorithm. This has been known based on its definition. Now, this algorithm, how it is going to work? Let us see. This algorithm compares character by character from left to right. If you have given a text from left to right, it is going to compare character by character, that is one value with the another value. But whenever a mismatch occurs, if suppose I have given in the text A and in the pattern it is B, if there is a mismatch, in that case, what happens? It uses a preprocessed table called prefix table. And we will be seeing about what is this prefix table. To skip characteristics comparing with the while matching. That means if I am not finding the exact match, then we are going to use this prefix table. But in the brute force algorithm, what we did, if there is a mismatch, just we are going to move one position left, and based on that again we start comparing the elements from the starting from the text onwards. That is the process that is happened in the brute force algorithm. But here we are not going to repeat that same process. Here we are going to skip them, and we are going to start taking this prefix table. Based on that, we are going to start our comparison. That's why this prefix table is more useful in the KMP algorithm, and this prefix table is also known as LPS table. And what is this LPS stands for? What is the full form of this LPS? That is nothing but longest proper prefix, which is also called as suffix. Prefix and suffixes we know, right? What is prefix and what is suffix? Suppose I have taken a string ABA. What is the prefixes we can write? Prefix means the previous one, and suffix means the next one, right? This is based on the prefix and suffixes we are going to write it. Let us see with an example so that you could understand what is this prefix and what is suffix. And this is the algorithm where we are going to use for our pattern matching in KMP. Based on this, we are going to construct our LPS first. Okay. Instead of saying this in the Sudoku format, let us see that in the algorithm, stepwise how we are going to construct our LPS table. Define one dimensional array with a size equal to the length of pattern. How much the pattern you are going to take, that pattern length, suppose I have taken my pattern length as some 4, right. In the same way, the suffix table, that is that LPS table also should have the size as 4. First we are going to do that one. This is nothing but within one dimensional array we are going to represent it like this 0, 1, 2, 3, right. 4 values 0, 1, 2, 3, that's all. 1, 2, 3, 4 values we can store into this. And define variables I and j. We are going to use the variables I and j to set our I and j values for storing our LPS table. And in this, at the starting stage, we are going to initialize our LPS of 0 equal to 0. That means initially we are making this LPS of 0 will be initialized to 0. And we are going to set I and j values. I and j values, I is starting from 0 and j is starting from 1 onwards. Now compare the characteristics at the pattern I and pattern j. Now we are going to make the comparison of the pattern. At the same time, I and j, both the things, we are going to check these two values, again these two values, like this way we are going to check the values. If both are matched, then we are going to set LPS of j equal to I plus 1. We are going to change the value of LPS of j, and at the same time we are going to increment both I and j values. I value and j value is going to be changed. Otherwise, go to step 3. Again, after doing this, again we are going to repeat the same process. Again we are going to check pattern of I and pattern of j. We are going to repeat the same process, and if both are not matched, if it is matched, we are going to do some process. If both are not matched, check the values of variable I. If it is 0, then set LPS of j to 0. In this previous case, we have set it to I plus 1. At the same time, we have incremented I and j values. But here, if it is 0, then we are going to make LPS of j to 0. And we are going to increment the j value by 1. Only the j value we are going to increment, not the I value. If it is not 0, then set I equal to LPS of I minus 1. Again, go to step 3 and again we are going to check pattern I and pattern j are going to be mapped. That is, we are going to check for the matching. And repeat the above steps until the values of LPS are filled. Right? Now, with an example, we will see how we are going to construct our LPS table. Let us see here. This is the pattern which I have taken A, B, C, D, A, B, D. These are the pattern which I am going to have. Now, based on this pattern, I need to construct an LPS table. Let us see. What is the size of this pattern? The size of pattern is 7. Based on that, we are going to have an LPS table with the same size. That's why we have started from 0 to 6. Now, define the variables I and j. As the algorithm we have seen, I and j variables has to be defined, and I starts from 0 and j starts from 1, and initially LPS of 0 should be 0. That means we are filling this value to 0. Okay. Now, I equal to 0 and j equal to 1. Now, we start comparing pattern of I and pattern of j. Now, see here, this is pattern of I and this is pattern of j. Now, we are going to compare these two. Now, what we are going to do, if both are matching, then we are going to do something with LPS. Otherwise, if it is not matching, we are going to do some other step, right? Now, compare pattern I and pattern j. What is there in pattern I is A. I have shown you in the previous example with the j. Both are not matching, right? Since both are not matching and also I equal to 0. So, we are going to set LPS of j is also 0. LPS of j is nothing but this is I and this is j, it is representing. Now, this one we are going to make it to 0 and increment the j value by 1. That means now only the j value is updated, not the I value. I value is 0 only. Now, again start comparing your pattern of I with pattern of j. right? Now I is at 0th position only. Now we are going to compare with j. Now observe, this is your I value and now this becomes your j value, this one. Now again both are matching? No, both are not matching. Now again we are going to check with LPS of j should be assigned to 0 and j will be incremented by 1, right? I becomes 0 only, j becomes 3. Now again you are going to compare I with j will be incremented, now j becomes this one, right? Now again repeat the same process, a and a with d, both are not matching. I is 0 only, LPS of j is to be assigned to 0, that's why we are going to assign this value to 0 and j value will be incremented by 1. Yes, j will be updated. Now again, now we are going to again check pattern of I and pattern of j, that is a with a. Yes, now we have the match. Now you can look into here, these two are matching. If both are matching, what we need to do? Now both are matching, LPS of j equal to I plus 1. We need to take the I plus 1 value. LPS of j is nothing but this one, this position. This position should be placed with I plus 1. I is already 0, 0 plus 1, that becomes 1. Now increment both I and j values by 1. Now you need to increment the I value as well as the j value. Both has to be incremented, right? Now I is 1 and j is 5. Now let us check. Already we have seen the pattern, right? Now I with the j will be checked and in that I we have the character b and j also we have the character b. Again matching is there. Now in this case again LPS of j equal to I plus 1. Again we are going to increment the I value, at the same time j value also. Now I is how much? I is already previously it is 1, 1 plus 1 is nothing but 2, right? That's why we are going to get the value of here, this is 2. And at the same time increment the I value and j value. I should be 2 and j should be 6. Now again compare pattern I and j. Here in pattern I you have C and in pattern J you have D, right? In this case both are not matching. Now again we need here one more case we are coming with. Here I not equal to 0. In the previous case I equal to 0. That's why we are directly setting that LPS of j equal to 0. Directly we are doing this. But here I is not equal to 0. That's why we are going to use some other case like I equal to LPS of I minus 1. What it is going to return? LPS I equal to LPS of I value is previously 2 minus 1. Now what is your LPS value? LPS value is 1. Now what is there in LPS of 1? That will be reflected in this place, right? LPS of 1 you have 0. That's why we are going to get the value of 0 in this place, right? Now you can see here we are going to get the value of 0. Okay. Now again we are going to check I with the last value we have D. Both are not matching, so that we are going to place LPS of j and I equal to 0. At last we are going to get the resultant value of your LPS table is this one. Now this table we are going to use in skipping of some characters, right? Previously in every step in brute force we are going to move in every step and based on that we are going to compare each and every character. But here in the KMP we can skip some of the characteristics and based on that we are going to have the pattern matching. Because of that the time complexity is going to be reduced in this KMP. Let us see the example also here and how to use this LPS table in this KMP. Let us see what are the steps we are going to follow in this. We use the LPS table to decide how many characters ought to be skipped. I said you right. In brute force only one step we can move and again we are going to start checking the character by character. And here how many characters to be skipped for comparison when a mismatch has been occurred. If a mismatch occur with the text with the pattern, in that particular case no need to skip off only one character by character. In this case we can skip some of the characters and move the pattern to a particular position. That can be done in this KMP. Because of that the comparisons are going to be lesser compared with the brute force algorithm, right? When a mismatch occurs, if the pattern and the text mismatch occurs, check the LPS value of the previous character of the mismatched character in the pattern. If it is 0, then start comparing the first character of the pattern with the next character to the mismatched character in the text. Let us see with an example so that you could understand very clearly. If it is not 0, if it is 0, we are going to do something, and if it is not 0, then we are going to start comparing the character which is at the index value equal to the LPS value of the previous character to the mismatched character in the pattern, mismatched character in the text also. This is the procedure where we are going to apply. Let us see all these steps with an example so that it will be clear for you. Let us take this example. How the KMP algorithm works. This is your text and this is your pattern, right? And this is the LPS table. How we find this LPS table, we have seen it, right? Now, this is where we need to compare, right? Start comparing the first character with the first character of the text from left to right. That means this is your text and this is your pattern. We are going to compare these characters. First with first, second with second, third with third, and fourth with fourth. But there is a mismatch here. So that when we have a mismatch at pattern 3, now what we need to do? We need to consider our LPS table. LPS also not the exact character, the value which you are finding at the index, we need to take the previous value of it. That's why we are taking LPS of 2 we need to take. Instead of taking LPS of 3, we need to take LPS of 2, the previous character we need to consider. And since LPS 2 of value is 0, if you can see this LPS of 2 is 0, the same thing we have represented, right? Now we must compare the first character in the pattern with the next character in the text. Right? We need to move this one to the first character in the pattern with the next character in the text. That means we need to shift this, and again we need to start comparing with the first character and the next character in the text. Here we need to start, and here this has to start. That means we are shifting the pattern to here, and again we start comparing. This is the one which you need to do. Let us see now where it has been started. Let us see the same step what we have done. Start comparing again the first character with the pattern with the next character in the text. Again start comparing from here. Both are matching, these are matching, this is matching and this is also matching, and here this is not matching. Now again what we need to do? The pattern is not matching at index 6. No, now what we need to take? We need to take the LPS table. LPS table of previous value we need to take. That's why we are taking LPS of 5. Right? What is there in LPS of 5? LPS of 5 value is 2. If you can check the table, you can find the value as 2. Now, we compare pattern to character with the mismatched character in the text. Now, where it is mismatching, from there we are going to start comparing. Right? Let us see how it could be. Yes. Now, we have shifted from here to here. Observe. Up to here it will be previously. Now, we are shifting this to the left, and these characters we are not verifying. The mismatching character where we have, that one we start verifying. Again after placing this, again if you are going to check here these two values, again it is mismatching. So that we need to go for the LPS. LPS should be the previous value, so that we are going to take LPS of 1. LPS of 1 value is 0. So that we must compare the first character of the pattern with the next character in the text. Now, how we are going to do that? Now, we are going to shift it again. Just observe. Because of this mismatch, we are going to shift the complete one to the left, and these many comparisons no need to do. Just we are shifting the complete one and again start verifying from the text and the pattern. Up to here, there is a match. But here, for these two, we don't have the match. Again, we need to use the LPS table. LPS of 5. LPS of 5 value is 2. Now again pattern of 2 character with the mismatched character in the text. Again we need to shift it, and we need to check it. Right? Now we are going to check it. Now if you can verify here, all the characters after shifting are matching. So that we can say that that particular pattern is present in the text. But where it is present, that index we need to return. That index is nothing but the 15. This is the 15th location where that particular pattern is there in your text. This is where we are going to implement our KMP. By practice, you will be getting this example. You can solve this example with this, And what overall summary of this pattern matching is, one thing we have seen about what is KMP and who have invented this KMP, and how we can use the LPS table by using this, how we can construct an LPS table in the KMP, and how that can be used in our KMP algorithm. And we have seen one example problem, how a KMP algorithm is going to work for a text and a pattern, right. I hope you understand this. Thank you.